Okay, so let's start from the beginning. So how usually we think about front end in general, and how people think about micro-frontends in general. So vast majority of the time, when I speak with customers and with teams that are approaching this idea of, okay, we need to scale our business. And till now, majority of the time, the first thought was, let's focus on APIs. And the answer was cell-based architecture or modular monolith or microservice. But the problem is that in reality, you cannot really think in a vacuum only about APIs, also front end as one part, and same for data. So if you think about the history of distributed system, more or less, we're talking about 2005, the word microservice was coined. And then in 10 years later, we had like first micro-frontends, and the year after we talk about data mesh. And if we start to look into these things, we are basically three big pillars of every application. It is front end, back end, and data that are trying to be modularized, not only at creating, let's say, some modular code inside that, but also dividing them in different parts. And for front end, the problem that I encounter is that majority of the front end developers are struggling with the concept of distributed system. Therefore, if you see a website like this, that is quite normal. If you think about an e-commerce, you have marketing message, we have new products, bestseller, offers. This is like big classic. People start to think that, oh yeah, we just take these components, like they call it, and then we break it apart and we compose at the runtime. That's usually how they think. But the problem is that, unfortunately, distributed systems are more complex than that. Therefore, we cannot really approach this thing in this way. That's the real problem. So who am I? My name is Luca. I'm a serverless specialist in AWS. Before that, I was VP of architecture in a company called The Zone, where I mastered this idea of distributed system at scale. So we had like a complex system that ran on 50 different targets between web, mobile, living room devices, so smart TVs, set-top boxes, and consoles. We have very interesting challenges over there, especially for fragmentation, because we move from a Panasonic that has like 3 updates per year, because you need to flash the firmware on the device every time, so if you want to update, to I don't know, a Roku device, very let's say well-known in US, but with a specific language called BrightScript that is XML-based, complex to build, stuff like that. So we have a variety of devices. The majority of the devices that we need to target were low-end devices. So the one from, I don't know, 2012, 2010, because if you think about that, you don't change the TV very often. It's not like a mobile phone that maybe you change it once a year or every 2 years. Like TV is like for 15 years, you have the same TV and the penetration is still that. And therefore, this idea of decoupling ourselves from the distribution part completely and say, okay, we send you an empty shell where we can send our application that shows the icon inside your TV, and then load at runtime all the different content, was a perfect fit for us. Surprise, surprise, 10 years later, this model is what every company, large organization, enterprise organization wants to have for their front end, not only for the back end. So when I started in 2015, the term micro-frontend didn't exist. And I was the second tech person hired in this company. And the CTO told me, listen, Luca, we need to move from, 15 people to thousands of people in a short amount of time. So wherever decision you take in your architecture, you need to take into account that we are going to grow very fast. It wasn't wrong, because in basically 2 years, we moved from 15, 20 people to 3,500 worldwide. And the tech department moved from 2 people to 550. So the recruitment was a nightmare, as you can imagine, but we were spread across 4 dev centers, 1 in Poland, 1 in Amsterdam, and 2 in UK. When I walked into the room with quite a few developers, we're talking about 60 developers in that room, and I pitched the idea of, we're going to do something that no one has tried. and we are going to do it this way, I had to coin a term. So micro-frontends was coined later on by ThoughtWorks, but the idea is that the definition for me is the technical representation of pieces of domain with independent implementation with same or different technology that is quite common. They should minimize code share, they should own by a single team. So the highlighted part of this definition is where we are going to discuss for the first part of the session. Because I believe that we need to map these things into what it means for organization and for the technology part. So let's start with the first part, or what is the difference between a micro-frontend and a component, because that is the key aspect of that. When we think about the component, think about, for instance, a button. Okay, it's the most common component that you can think about, probably the most simple one, but at the same time, it provides the idea. So in a button, usually when you build that for a design system, you want to expose a label, because the button can be used in several places, right, in a website. So you have a property that you expose, and someone is filling this button with label. Then potentially you can add an icon into that. So if the icon is set, you display that, otherwise you display only the label. Then you can add change border color, different rollover animation. If you start to have localization, you can also have auto size dimension, because we know that in German, the word is usually 20% larger than the British one or the English one or Italian one. And finally, you want to use for form. So you have the possibility to disable the button, enable the button, and so on. But the reality, if you stop for a second and look into that, so you have this API, the real knowledge on how this button should be used is the container of the button that knows how to behave. So the button in reality is just an abstraction that is used for minimizing the code that is written, and you centralize in one place and you use in multiple others because you have this abstraction. But if you need a new feature, you need to go back to the button, add this feature, and then change in every single part. But unfortunately, components are designed for reusability, are not designed for scaling. So what you do usually, and you don't have to take my word on that, you can let's say read from Neil Ford, reuse this form of coupling, because I'm reusing a certain part, and then I start to have certain behaviors that are not, let's say, code related, but are human related. The fact that you have an element in a monolithic system that is abstracted, changing that is very quick. But if you think about it, in distributed system, imagine you have like 4, 5, 10 microservices that are using a login line that is shared across elements. And suddenly you need to do a massive change. I need to coordinate multiple teams that are owning that microservices to change that part simultaneously, because otherwise you're going to have discrepancies on the outcome of that. And similarly here with micro-frontends, we need to so a micro-frontend compared to a component that encapsulates state. Very often, if you think about the component is it doesn't have the state of the application. It has its own small internal state that can say, okay, I'm selected, not selected, stuff like that. But it's driven by an external entity. Micro-frontend shouldn't be driven by an external entity. Otherwise, we are leaking the domain into the container that we don't want to. It has to be context aware. So it needs really few information in order to really understand how it could work. Usually defines input and output very clearly. This is a classic thing that on microservices we learn very quickly. API contract first. So we start to design a service based on the API, and then you decide how the schema and the other things will work. Why that? Because it will enable different team, consumer and producer, to work simultaneously on this API. If I define the contract up front, then whoever is this consumer or multiple consumers can start to work without me implementing this thing. As long as the contract is respected, we're happy to go. This is something that we have done for a lot of time. And finally, a micro-frontend should be less extensible. We are not optimizing here for reusability. That's not the goal. We are optimizing for reducing the external dependencies of a team, and we're optimizing for throughput. So having a fast flow, so moving very quickly for one team that is owning a chunk of the system and deploy as fast as possible to production and learn from that. Because we know that we are working on an empirical environment. It's not scientific. We cannot say, oh, we give you the same specification to two teams and we produce exactly the same thing. Maybe someone can decide to go with Ruby and something else, and someone else is using .NET or Java or whatever. So, and the way how they're implementing the same, let's say, contract, the specification is completely different. And it's fine, because we know that we are working in an empirical world. So in the case of micro-frontends, boundaries are the key things. As we said in the definition, we are talking about business domains. We're not talking about components, technical components. And therefore, when you think about testing boundaries, few rule of thumbs that I usually use is that first, you tend to reduce the API exposed to the container. So micro-frontends needs really not much. Usually an event emitter or an ID that you want to inject. But that's pretty much it. The micro-frontends itself knows inside this logic how it should behave and what it should do. As we said, micro-frontends are context aware, and you don't optimize for reusability or cost. There are situations that I have seen micro-frontends reuse in a good way. Give you an example. Imagine a multi-tenant project. This company was from Canada, and basically they built the software that you have on when you go to the restaurant, the till that is running on an iPad or a tablet, right? If you think about that, the vast majority of the time, there is a commonality around this stuff. Every restaurant is required to have like a subscription, obviously, sign in and authentication method, maybe some settings and other stuff, right? But there are some parts that are peculiar for the restaurant. Think about the map. Vast majority of the time, if you go there is a map and you select like where to put the table and other things. And plus other restaurants that maybe have some, I don't know, fidelity cards or whatever that you want to apply. And this company basically leveraged the idea of micro-frontends for doing exactly that. 80% of my software is exactly the same, but that 20% can be customizable. So it can be a feature that we offer to our customers in order to, let's say, differentiate us from the others. And therefore, they deploy all the new things on the 80% of the part independently, and they don't need to retest when they deploy the custom part. It was a pain for so many years because front-end is by far more difficult to do end-to-end testing if you don't have the right people. Still today, there are a lot of manual QA that are testing application and are very onerous because sometimes I worked in a certain project where they took like longer to test than to write code. But they couldn't go out till they have the green light from manual QAs. And we're talking about weeks compared to hours. And that's not acceptable in modern software. Last but not least, another rule of thumb is if you find yourself to have like, I don't know, 20 micro-frontends in the same view, usually you're dealing with a distributed monolith. So you have like a distributed runtime components that are loaded, but not micro-frontends. Micro-frontends, usually a good rule of thumb is having, I don't know, 5, 6, 7 micro-frontends in a view is already a lot. So that is one thing that we need to be aware. The last but not least, like domain-driven design teaches us, boundaries are not forever. The way that of today you are slicing your application, your micro-frontends application, it might be that in 6 months you need to change it because one part of the system that was pivotal at the time maybe didn't, let's say, penetrate properly with your customers, and therefore you can decide to collocate the code more than, let's say, maintain this modularity, deep modularity with multiple micro-frontends. You can just collocate just a larger chunk and instead invest in the time to make more modular another part of the system that require more changes. Because when you think about how to slice any system, front end or back end, doesn't matter, you look into one of the metric or heuristic that we are going to see tonight, that is rate of change. And rate of change matters because rate of change, you can define that in a system, there is an area that doesn't change very often. There is a high, let's say, rate of change at the beginning for building that, but maintaining it, it's no brainer. Think about, for instance, I don't know, FAQ, or think about contact us, stuff like that. You have to build that, but when it's built, how often do you change? Once a year, probably less. So it doesn't matter really if it's, let's say, written in a monolithic fashion or not. What it matters is that you need to apply the right modularity level or granularity in the part of the system that requires to have a certain rate of change, because otherwise, you are just wasting energy. There are some organizational benefits that are important for micro-frontends. So let me give you an example. Usually when a company decided to go with micro-frontends, it's they're looking for incremental upgrades. I give you a real data point here. In my previous company, as I said, we were like 550 people when we, let's say, after a couple of years in the tech department. We moved from, when we started to have micro-frontends, we moved from roughly 2-3 deployments per month to 25 per day per team. Because we had like we will see later on in the presentation, but we have basically created this safe net that enables developer to, let's say, shape traffic towards a new version of a micro-frontend and test completely independently. Because our work behind the scene was trying to make sure that the boundaries doesn't create, let's say, obstacles to deploy independently. So we analyze very often, let's say, we are creating friction in the trenches. There are, let's say, enough capability for developers to ship. Do they have, let's say, any problem? And very often I was going physically before pandemic to the desk of developer in, I don't know, Amsterdam or Poland, whatever it was, asking what kind of problems they see, or if the boundaries were too coarse grain, or if they are too fine grain, and what kind of issues that they see in the trenches. Because in reality, if you think about that, architecture should enable a certain behavior. It's not, let's say, a rubber stamp that you put on a piece of paper. You need to use architecture in order to apply characteristics inside the system. The second thing is decentralization. Very often people think immediately decentralization on the technical side. Like I'm in a team A, and I have my micro-frontend or microservice, and I have my domain well shaped, so I'm decentralized. I can do whatever I want. The problem is that distributed systems in general, they don't work unless you take into account the organizational structure. If you decide to go with microservices for solving or let's say organizational problem, I can guarantee you that if you don't touch the organizational structure, they're not going to work. I'm not mentioning the silver bullet at all. What they do though are extremely, if you apply, let's say, multiple dimensions inside your social technical system, the decentralization mindset. So you delegate to the developer a certain set of choices. You own in the tech leadership basically the overarching ideas of what to do and what not to do, but the developers has to have skin in the game. Now the teams should take decisions, should decide that based on metrics that maybe they're exposed to, they should use a technology over another one or a pattern over another one. It's not anymore like in the past when I was working as a developer, the tech leadership decide the majority of the patterns when to use what. Developers now decide autonomously because inside their area they became domain expert, and this is important. It's a huge shift compared to the past. Another cool thing was team cognitive load reduction. So in order to achieve, let's say, the scale that we were working on, and this is something that I have witnessed with several customers as well, we basically had every other week a new team joining the company. As you can imagine, for me, one metric to understand if this architecture worked was also how fast a new team that never seen the system, they don't know, obviously, live sport in our case, but any domain that they're working on, how fast they can move from, I start to understand a bit about the domain to deploying production. So the average was 1 month for a brand new team that never seen that domain before. Because we hire people that know about, in our case, was React as a UI library. But the interesting part was that because they didn't have to know all the complexity around the system, all the different pattern applied, they have their own area that they can learn from. And the only thing that they need to do is literally start to write code on their area. So they have the requirements ready. They just need to map them and start to deploy. Easy. And that was pretty cool, honestly. Many companies are looking for that. The other thing is we need to remember, as I said before, that we need to scale not only the technology, but also the organization structure. And that leads us to the other interesting thing. So the Conway's law. I think quite a few of you probably have heard about that. If not, basically, this is the definition where usually design a system that we produce the design of a copy of organization communication structure. This is from 1967. At the beginning in this white paper, when Conway's shared it, no one believed it. From 80s onwards became, let's say, the Conway's law. And it's inevitable that you are stumbling across it. Because in reality, when an architecture doesn't work and there is friction that arises, the problem is never, vast majority of the time, it's not architectural. It's not architectural because you might see problem on the engineering part or engineering culture part. Or it could be on how you structure your organization or how you assign the domains to a team. Very often, if the problem is not where you think it is because of the Conway's law. It's quite enlightening. But an example that I usually make on this one. Think about, and it's a question I have like bazillion times. Should we use monorepo or polyrepo with micro-frontends? Both work because at the end of the day, they are just, let's say, applying certain characteristics inside your teams and your engineering culture. When you decide to go with monorepo, what happens behind the scenes is that you are saying to the teams, intrinsically or not, that they will be able to have visibility on the entire system. You have the high discoverability in a monorepo. So I can see how another team is implementing their stuff. I can retrieve information from there and start to implement on my side. But at the same time, you have more complexity to handle on how to create your automation pipeline. Because when the project becomes big, then it starts to become complex. And you need to optimize heavily for having a fast flow in order to move from I write some line of code is available in production or is available in environment system. On the other hand, and there is also a risk if there are not very mature developers that you have, let's say, some abstraction that are not needed because it's very easy. I create a new folder, everyone can see that, I start to use that. And that could create ramification on how complex is maintaining a system. On the other side, if I work with polyrepo, I'm basically forcing, let's say, teams to work with API contracts because I cannot just share a library because I need to coordinate with another team. I don't have visibility on all the repositories because you are creating strong boundaries between teams. And it could be that in your situation, in a specific company, could work better. Because, for instance, I can choose the way how I want to use Git. Should I use a Git flow? Should I use a trunk-based development? Should I use whatever other things I want? That is possible in a polyrepo, while in a monorepo, it's not. Most majority of the time, you use trunk-based development, and you accept that the risk of doing that. So having everything merge in main, if it doesn't work, you need to fix very quickly because all the other teams are basically cannot deploy. So there are decisions that are not, that seems to be only technical, but they are not. They are way more complex. The implications are definitely bigger. So when I think about decentralized mindset, this is what was I was working back in the days. We're talking probably 15 years ago. In quite a few companies, UK and Italy, both of them was quite common. So you have like usually a tech leadership that decide more or less how the things are working. And then on the engineering side, you have an organic growth about team. So we need more manpower. We have the new team, but we don't care about how things are communicating together. As you can see, there are a lot of connection between team A, team C, and team A, team B, and team B and team C. So it's let's say not overseen. They just think about throwing features into the problem. But in this decentralized mindset, we need to be more careful on how we design the organization. That has a direct impact on how successful you will be inside a project. There is a fantastic book called Accelerate that basically is a research on over 200 companies, if you remember well, it's North America-wise, where they study what are the traits of successful companies. And one of the things is reaching fast flows. They came up with the DORA metrics that probably you heard about them, and how useful these approach are. And all the companies have this decentralized mindset where they start to work in what they call nowadays team topologies. So I was applying this even before was a thing. But if you didn't read the book Team Topologies, I highly recommend it. The idea is simple. So you have like some streamline teams that are the ones that are generating value for the users. Think about how you usually write code. You write code for a reason to generate a feature that could be used by different users. So here, for instance, you divide by domain. You have the catalog team, the onboarding team that takes care about sign in, sign up, etc., and personalization. And this team should focus mainly on the code, on generating value for the company, because the whole reason of being there is maybe it's an e-commerce or I don't know, on-demand platform, whatever. On the other side, though, you need other things, like you need a complicated subsystem team that is a data science team. You don't have, as a streamline teams, what I care about is I need to share some data to the data scientist team. How they use this data is not my problem. My problem is just flowing my data into their area that they can retrieve. So this complicated subsystem team is facilitating the access to receive data that they can own then and manage it properly. And that could be a set of APIs. It could be like an easy way or a standard way to flow data into a place like a data lake or a specific approach. Or it could be even working in a data mesh fashion, and therefore they supplement the teams, say, okay, remember every time that you build an API, you need also to create an internal API that we can query in order to create this business capability for the company. Then usually you have a platform team, and in this case, if you think about I don't know, Kubernetes or any other, but even serverless, if you think about that, vast majority of the time the platform team takes care about standardization. So you don't have to think about what is a pod in Kubernetes, how to orchestrate that, the controller, or the other things. We take care about that. So you use this thing as a service, acts as a service, as you can see there. And then you have like enabling team that are spanning across multiple layers. For instance, think about security. This is a classic example. In security, my experience when you are working in enterprise, usually have a ratio of one security architect every 10 teams, give or take. And therefore, scalability is a problem because you can decide whatever you want in the security, but unless you create like the bridges with the other teams, it's not going to work. And therefore, in this case, you need to create teams that are enabling others to express your intention. Sometimes you can automate them. And for instance, you can check in every repository if someone had the API key inside the code and block that, let's say, repository to be public and maybe spoil some security issues. You can do, I don't know, pen testing maybe inside your CI/CD and force every team to have that. Stuff like that could be done, but you need to look holistically into that. Here could be architecture, it could be developer experience, and everything. In this case, all this structure enables the streamline teams to focus on what really matters, features. And if you're capable to build a solution like that, or in a team structure like that, an organizational level, you will have distributed systems that start to thrive, because now everyone has his own, let's say, knowledge and capability. They work inside things. There are defined contracts like facilitating or access service and stuff like that, that are communicating across the different teams. And you can start to think to reduce the external dependencies easily and have streamline teams that can deploy multiple times per day. Now, the other thing is that platform exists not only for platform engineering, it exists not only for the backend, but also for the front end. Usually, I have heard call it core team or platform team, whatever you want. But the idea is very simple. A platform team defines the foundation for distributed system end-to-end, front and backend. There isn't any difference here. So in this case, when you start a Micro-Frontends implementation at the platform level or not, you start to think about, there are 4 decisions that I find every single time. This is I call it a decision framework. And there are 4 things that you need to define no matter what you design. First of all, you need to identify what Micro-Frontends are. You need to compose them. You need to route the request, and then you need to communicate. Those 4 things are happening every single time. Usually, if we start from the beginning, you start to identify Micro-Frontends. You can have 2 flavors. You can have either what I call horizontal split, that is basically the one on the left, where you have like multiple Micro-Frontends in the same view, or you can have a vertical split, where you have like a group of pages or a single page that is owned by a team. In this approach, there are a lot of things that we need to unpack. In the horizontal split, you might have multiple teams working that. So one team is responsible for product details, one team is responsible for reviews, and on the other side, instead, you have one team that is responsible for one single view or multiple views. And obviously, majority of the time, companies are starting with the vertical split. It's easier, it's simple, it's like having micro apps, if you want, that you own and you can easily work with.
Can I just stop you there at that point? Is everybody okay with pizza? Anyone not like pizza? Okay.
Pizza's good.
And does anyone require special dietary requirements? Vegan, vegetarian?
Vegetarian, yeah.
Then the second part is composition. Usually, micro-frontends could be composed on client or server side. Composition means basically I have like one or multiple micro-frontends. Someone has to load it. That was classic things. If you think about Java portlet, was the same thing in the past, but was not intentional. So it was like very scattered. We weren't thinking about how we want to structure that, but the idea is the same. We use an old backend called transclusion, vast majority of the time, where you just load chunk of HTML and load inside a placeholder, or it can be as simple as a JavaScript file that you load and you just say, okay, every time that you create in modern frameworks, they create this representation of a DOM tree in memory, and then they apply the changes into the DOM. You can apply that thing, and that could be a portion of the UI. After this, I will show you like a classic example. This usually, vast majority of the time, you have an application shell that is basically the blue rectangle that takes care of composing micro-frontends, so knows where to fetch a micro-frontend and load inside a container, and also takes care about routing. Those are usually the things that are working. And then inside, there are multiple micro-frontends. So client side is happening on the client side. Obviously, server side will happen on the server side. For the routing part, that is the interesting part, vast majority of the time on the client side is happening on the application shell, but could happen also at the CDN level. Very often, if you think about how CDN are working nowadays, almost all of them are offering some compute part. And you can use that compute part for applying some logic. For instance, in my previous company, I was using a Lambda at the edge, but it could be applied on everything. Akamai has it, Cloudflare has it, all of them has it. Some logic where every time that I request a micro-frontend, I can intercept the request and decide to redirect towards the direction. That was helpful as a strangler pattern, where you can say, okay, I have just this, I don't know, slash catalog is in the new word, but contact us is the old word. So I can say every time that I see contact us, I need to retrieve the old monolith, and I send that to the client. Or every time I have slash catalog, I will go to the new micro-frontends part. And this approach helps a lot. And I use as a strangler pattern, as I said, I use even for deployment. I could say every time there is a request coming in, I want that only 5% of the traffic goes to the new micro-frontends version. And the rest, 95% of the traffic goes to the monolith or the current micro-frontends version. So I can do like shipping traffic, like blue-green deployment, kind of release, stuff like that. So routing is happening here, and here it usually is happening only on the server, because usually on server side, you have to think that the navigation is pretty let's say, vast majority of the time in server-side rendering is hard navigation. So what it means is you make a request and the page is reloading end-to-end every time. So I go to slash catalog, I reload the page. I go in another one, I reload the page. With micro-frontends, we can mitigate a portion of that, but most majority of the time it's like that. So every time that you load the page, you have like a full rendering of the page. So the routing has to be there. Finally, if you go on communication part, this is not natural for front-end. Majority of the time, when you think about communication, people think we create a state manager or a state machine that is global, and everyone can see that. But the problem with that is that you are coupling things. Instead, what you're looking for is more an observer pattern. Observer pattern is designed for having a third object, that usually is an array behind it, or an observer. The observer is expressing to an array in whatever language you use. And every time that you are interested about an event happening inside the system, you just subscribe to an event. And that basically means that that object is available inside an array. And when someone wants to emit an event, it will emit an event, the server will pick it up, and it will go through this array, passing, oh, this event is bubbling right now. So it's just sent this event, and every single subscriber that was assigned to that array will be notified. Someone will pick it because they're interested, someone will not pick it because they're not interested. But in this way, you basically remove the complexity of handling communication with micro-frontends, because it's just an event. Majority of the time, you know, I've seen custom events implemented, but there is a caveat about custom events. Custom events are a web standard. Basically, is like a button click or on click or whatever it is, but it's custom, so you can generate an event in the way that you want. The problem with that is that they're bounded to the DOM structure. So if you think about an HTML page, you basically have a representation of a tree. And imagine that you have two leaves or two nodes of the tree. And this part has to communicate to the other part that is on another part, another branch of the tree. So if I want to make sure that this event is picked up, every single branch should subscribe or add an event listener at the window of object, so at the top of the event. How event works is, if you think about a tree, is that I propagate an event up to window, but there are multiple nodes between me and the window. Someone could intercept that event and stop the propagation. Debugging that is a real nightmare. And even if you are moving stuff around the DOM, you might risk that you are not, let's say, you're not taking into account the DOM structure. Event emitter remove all this complexity because it's an object that is external and available for everyone. And for instance, PayPal implemented exactly this mechanism for communication across. If you go to paypal.com on the web interface, it's fully micro-frontends. And they're using an event emitter because they enable the communication across boundaries. And when they want to communicate inside the boundary, so inside the micro-frontend, they use custom events. And this approach, dual approach to say, okay, if inside my control, I can control where is bubbling around this event. But when I need to communicate with the rest of the application, I use events, is more or less mirrored on microservices. Very often, you know, if instead of doing point-to-point communication between services, you use a discovery service or you use an event-driven architecture. It's exactly the same thing, just applying. Reactive streams is something that I thought back in the days would take more, let's say, interest in the front-end community, but the entry level for mastering reactive programming is too high, and very often it's not taken into account, despite some framework are offering, like Angular, are offering reactive streams out of the box. The other thing is thinking about ephemeral data and persistent data. So ephemeral data, it could be an ID of a product. So I move from, I don't know, the homepage that has a product that I want to select, I go to the product details. In that case, it could be that there are two different micro-frontends. So in order to pass which product wants to be loaded, you just pass basically the ID in query string. And by convention, the query string is available to everyone, so you will pick it up. But for more persistent data, like the session token, usually you use local storage or session storage, cookies better, or even in memory with web workers. Those are the most common approaches. Few consideration of the application shell, so the one that is containing all this stuff, has to be as vanilla as possible. So usually having a framework, it might create more harm than benefit for using that. If you're using, I don't know, a mixed approach of micro-frontends, having some of them in Vue, some other in Angular, some other in React. Having an application shell with a specific framework could create more problems than benefit. You should be context unaware. If you find yourself that you deploy a micro-frontend alongside the application shell every single time, it means that you basically some domain leaked into the application shell that you don't want to, because otherwise it makes more difficult maintaining certain stability of your system. Usually what it does is exposing initial configuration and much more to the other micro-frontends that is responsible for routing and composing. Now, before we move into that, let me show you an example of micro-frontends. Oh, hang on, probably they don't see that. Let me share again my screen. Give me a second. I was sharing, okay, desktop one. You should be able to see this. Yes. Okay, so let me go here. So this one is a micro-frontend demo that I created. Should be big enough. This one is composed by multiple micro-frontends. Those are completely client-side rendered. So we have this header that is inside the application shell. And basically, well, every time that you see this label that is saying which version of React I'm using, it's basically pumping the micro-frontend. So here I have a micro-frontend is called on page that is loaded. And for instance, if I click like this thing, is going into another micro-frontend that is the catalog micro-frontend. So we have home micro-frontend, catalog micro-frontend. And here we are inside the product details system. For you as a consumer, it seems a completely normal experience that you have for an e-commerce. But the beauty of that is these elements are completely independent. So I can deploy a new micro-frontend and it will be available on the header like this. I don't have to coordinate with another team. I don't have to do anything. I just need to use a configuration that basically enables to generate micro-frontend on the fly. The other cool thing is that here you see before was React 17. Now we are React 18. You can have multiple versions of the same framework or different frameworks living in the same project. What's the benefit of this? Usually when you are moving from a monolith, when you're working on a monolith, you want to update to a newer version of a library. You go in a package JSON, in the case of JavaScript, you update that, done. Obviously, it could be some crashes and issues and whatever, but that's pretty much it. In distributed system, it's not possible. Every team owns its own part. And maybe their backlog doesn't allow them to change on the fly. But with certain libraries, like the one that I'm using here, you can use these things. So we have basically now reloaded this part here, with all the different things. And now I'm navigating inside the catalog micro-frontend. So when I say back to catalog, I have a different view. It has its own state, as we said before. And I have like all the different product that I can navigate through the different product. And I have like the review, whatever it is. So in this case, the team responsible for the catalog will have this chunk and this chunk only to take care of. They don't have to test anything else. They don't have to think about all the other things. They just need to add new features in the catalog. That's it. In my account is interesting, for instance, my account is composed by 2 micro-frontends. And this one has the horizontal split, as was mentioning. If you think about my account, in a system, you might have like user details. I have my name, my email, my address, whatever. But I also have like some payment methods, right? So payment methods can be in a complex system, in a medium-sized application, that is another microservice and another team that is taking care about the complexity of payments. But for the user, you want to compose a view that combines both. There are different ways that you can do that. You can be that you spin up a backend for front end, and maybe you aggregate everything at the API level. But you can do also on the front end. You maintain the 2 independent teams. You just say, okay, I want to load both. And the beauty of this is that I'm capable to have 2 different, let's say, independent applications that I can update payment without notifying the other team that there is, I don't know, now there is a new button color, or there is a new functionality. I want to see the history, how many changes or payment method changes that happen in the last X years. So stuff like that are completely independent. The other thing is the communication. If you remember before, we were talking about communication. Like, for instance, a classic behavior is I do something, I interact with some elements inside my application, and I want to show a model window that something happened. The model window should be standard for everyone, right? So what you can do, leveraging the event emitter approach, is sending an event, the application shell will pick it up and will have this model window. So for instance, this case, if I change the default thing, this toast notification, payment method updated, is basically triggered by this micro-frontend, but it doesn't, this part is not, this toast notification is not owned by the micro-frontend. It's owned by the system. And it's just saying, by the way, and you can see also here, notification received, here we are. So this one is basically the object that I have. Let me increase a bit. This is the notification that I have that is saying this is the title. So you need to, obviously in this case, because it's a notification, it could come from payment, it could come from other places. So you need to be very standard in the way how you are handling that. But it would be like, for instance, the message is MasterCard ending, blah, blah, the title and type success. If it fail, it could, you just say type failed or error, and instead of being green, it would be red. So you will have some standard that you define when you are communicating in this situation, but that could be something that you communicate globally, or it could be that you communicate between the two micro-frontends. Potentially, I can trigger an event that every time that there is a change on payment methods, not only the application shall subscribe to that, but also the user details, and maybe want to change something there. Okay, so there are a lot of flexibility into this stuff. And the beauty of all of this is that I can have teams that are completely independent. So I can redeploy my homepage 20 times per day, and the other team I don't have to deal with. Unless there are, so let's say, specific things like we want to change the design system of the entire application so that instead of doing iteratively, you can do in one go. But the beauty of this approach is that it works in that way. Yeah.
How this micro-frontends communicate with the backend, with the context of session?
Yeah.
Because when you're retrieving catalogs, you need a session and
absolutely. So the classic thing that you do is using a middleware. So every time that, for instance, if I do sign in here, and I add my, I don't remember what is this one. I guess that this one doesn't work. Oh yeah. So in this case, every time that I make a call to a backend, what it will do, it will append. So in JavaScript, you have the possibility to override objects. So the fetch API is a standard in JavaScript, and basically is calling an endpoint. What it can do is overriding it. So every time that you are using a fetch API, it will append the session, the bearer token as header. So for micro-frontends, you don't deal with that. It's the application shell that basically handles refresh access token and errors, whatever. So for micro-frontend became transparent. This is one approach. Another approach is basically setting in the cookie HTTP only, and that basically the browser will take care on every time that you make a request to append the cookie itself inside the thing. There are also custom implementation, but usually those two are the ones that I have seen more implemented. And again, it's just in this case you do once and you have like for everything. So you don't have to, let's say, every micro-frontend implement their own stuff or creating a library. That's literally, you shall take care of that. Let me show you one thing on that I think is interesting. We will drill down, and probably I will show you later when we arrive to the point. The other thing is, the other problem we have in micro-frontends, like everything in JavaScript, is which library framework should I use? So, vast majority of the time, this is the situation. You have so many frameworks and possibilities that you are puzzled. And that basically was me when people start to ask me this question, right? The reality is it depends. And it's not to be, let's say, pedantic on the idea is, oh yeah, but because we are architects, we should always answer it depends. But it's mainly because you need to understand what you want to express in your architecture. That's the main challenge. Developers often will decide the library based on hype. So what is the latest trend? What is the coolest thing that people do? What works better for my CV? For me, it's more about, okay, what I need to express into that. Do I need to do client-side rendering? Do I do the server-side rendering? What level of security I need? And all this kind of question, what people call non-functional requirements, but I hate that name. I prefer to call architecture characteristics. That's more positive. Those are the questions usually that I ask myself. So, okay, if I do client-side rendering, what kind of frameworks are available? What do I want to use web standards? What are the skills inside my team? These kind of questions usually lead towards the decision. I can guarantee you that I've seen implementation working in different shape or form. It doesn't matter which framework they're using. Some of them have more functionalities out of the box. Some others you need to build by your own, and then maybe it's fine because you have your whole Netflix and you have a lot of teams that can work on this stuff. Or you have like a lot of engineering maturity, but some others maybe they want more have a battery included solution. So that for me is less important. The thing is, and that's another thing. I want to give you a classic example here. I was talking with the team, internal team, a month ago, a month and a half ago, and basically they were thinking about using this library called Module Federation because that is one of the key or most well-known library, and it works extremely well for client-side rendering and front-ends. But when I started to ask a few questions, it became clear to me that they didn't ask themselves these questions. So one thing that they wanted is having independent micro-frontends that use wherever library they want, despite the version, the technology, whatever. They don't have control over the micro-frontends, how the micro-frontends are built. There's not like an internal team that they can, like a sister team, say, listen, can you change this library in this way? It could be that they have using libraries that are basically jeopardizing their effort as a team, as a platform team. And the other thing is it was a B2B application. So everything is behind authentication. There is no need of SEO, organic SEO, retrieval, whatever. And few of those questions, when I started to, let's say, dig around what they were talking about, at the end I said, listen, you know what? Your best possibility to implement micro-frontends today is an iframe. And despite you say, oh, but the iframe has bad performances and have these things, in their context, it's a B2B application. They don't have control of what other developers are doing. They cannot ask for changes because they were just a chunk of stuff that was served to them. They just need to collect these things and provide a seamless experience for the users. iframe are a perfect fit. They can control the security level. Nothing leaks outside the iframe if they want and if you configure it in a certain way. And they can have like one, where they can decide where to put the iframe. As long as they decide that the way to communicate is through message for iframe, they're good to go. They have way less burden than using any other framework out there because the security level that the iframe offers is still unmatchable. And therefore, in their situation, they went with iframes. Another example could be the AWS console a few years back. The security team decided to have iframes for composing the UI. So if you go at the beginning, there were like some nice iframe that were separating the AWS console, if you're familiar with that. And that allowed every team to build their own stuff in the way that they wanted without coordination. So they reached basically the goal. So again, don't be fooled about let's follow, let's say, the latest and greatest, but let's try to understand what we express. Now, the other thing that the platform team should take care of is the developer experience. You know, very often this is an afterthought. Many companies they don't have like a developer experience team. They don't have things that, let's say, are intentional. Often there are some principal or staff engineers that are building some tiny tools, but then in 6 months time, they are not maintained properly, whatever, and therefore it doesn't work. But you need to create like some stuff like guardrails. An example of front end that is for me very successful that I implemented in the past is a budget size for micro-front end. So if you think about, you have like, I don't know, tens of teams completely independent that are shipping stuff in production. One thing that I notice is that especially less, let's say, knowledgeable developers, where let's say adding features. Adding new features, but adding also new libraries. So a tiny application, a tiny portion of the application that move from 10 kilobytes to, I don't know, 500 kilobytes. How is possible? Because they forget to make some configuration, maybe doing tree shaking, whatever. So I started to create budget size for every single micro-frontend. So I know I had the baseline. We checked that was more or less optimized the micro-frontend. And we said, okay, so your micro-frontend is 50 kilobytes. Now, you have the possibility to increment by 30% your micro-frontend size. That's it. But we check. So every time the developer open a pull request, we were using the webhook of Git, and then spinning up a Lambda function that was basically incorporating Webpack or Rollup. That was the two bundler that we decided to use. We were building on the fly the artifact and checking it was inside the threshold. If it wasn't, they couldn't even merge inside main. This feedback loop was designed not in CI/CD, but at the Git level, because the feedback loop for developer was super fast. I'm building stuff, I open a PR, oh, it's too big, let me go back, and I fix that. If it was too late into the process, developer probably would have already started other free features. So we need to think about guardrails that are fitting inside the way how developers are working. Now, another one is updating shared libraries. So imagine that you have free shared libraries, but now you have like tens of teams completely independent. You want to make, let's say, their life easier. Perfect. I have a design system that has to be updated. I configure dependable that is available in GitLab, GitHub, whatever things you want. It's just a tool that scans through all the repositories and says, okay, so in JavaScript, I need to check the package JSON. Let me check that they are in the latest version of the design system. If they are not, I open a PR overnight that has the new version. So the developer the day after will see that the PR available there. Or I can even create a PR, merge it, and the developer, when clone the project the day after or update the code, it will see some errors, but they know where to find. And that is the way how you create guardrails to enforce certain behaviors inside the distributed system. It could be security posture, scanning for APIs, keys that are inside the code and stop that. And any other architecture characteristic that bubbles in your head that you want to express inside your system can be done through guardrails. That's why developer experience is so important. And one thing, a trend that I've seen over and over again nowadays is this idea of using an API portal, or in this case, it's Backstage, is an open source service created by Spotify back in the days. You install inside your machine, container, whatever it is, and it's used for backend and front end. It's basically a single point for developers to retrieve APIs, to retrieve documentation. Because very often, you know, you have like Jira, and then you have like all the different the suite, Atlassian suite for all the different information. Here you can have like API spec. You can have, for instance, in this case, templates. It's very common. In distributed system, front and back end doesn't matter. So you can create like a template, say, okay, I want to spin up a new service. I don't have to start from scratch. I just go here, clone the project, boom. I already have all the libraries set up, or the configuration for AWS set up. I have, or in Micro-Frontends, I have the latest framework used and all the other things that are used for all the other Micro-Frontends. So you are creating guardrails to start properly and not go off rail. And I think these kind of things are extremely helpful. Backstage nowadays, I cannot say it became a standard, but all the companies that are doing seriously the distributed system are using it. Because it's very nice. The other cool thing is because it's open source, a lot of companies start to contribute with plugins to Backstage. Imagine like it's like if you think about the architecture of Backstage, it's like Eclipse. That is a plugin system. So I want to build a plugin, and it works nicely and seamlessly with the other. The third part is the deployment that we should take care of. For me, are three characteristics that I usually use every time. So first of all, I want to have incremental deployment, frequency. So I want it very frequent. I prefer to have code in production more than having a bazillion of, let's say, gates that at the end of the day in distributed system don't work, no matter what. And I want that are independent. If I found myself that I need to coordinate the deployment of a portion of distributed system, is a failure. There is something wrong with what I've done. So with a group of people that are mainly frameworks maintainer, of Micro-Frontends frameworks maintainer, we create a working group for a year, and we create what is called a discovery working group. And the discovery working group generated this JSON schema, and nothing is not, let's say, groundbreaking, but the idea is I provide a unique ID to identify a Micro-Frontend, where to find a Micro-Frontend, so where to load it, a fallback if you use multiple CDN. There are a lot of people that are using 2 CDN for serving Micro-Frontend, so if one doesn't work, I go to the other one. Some information, standard, integrity version, and then an extra extras object that contains wherever you want. Some customers or some people are implementing for, let's say, role-based behavior. If you're an admin, you have access also to this feature. Some of them are using for feature flags. Doesn't really matter. But here, basically, you can decide wherever you want. And that was super cool because obviously, if you think about that, the pattern will be I have an application shell, I call an endpoint, I receive this JSON that contains all this information, and then I load the micro-frontend, right? The cool thing of this is that I didn't mention this one is an array, right? So that means because I'm requesting let's say a micro-frontend that is loaded at runtime remotely, it's not bundled inside my code, it means I need to pass through the network. And if I pass through the network, I can use canary release and blue-green deployment that on frontend are not standard. You need to bear in mind that. It's something that is brand new to a certain extent. For microservices, we have that for ages, are built in many services. But for frontend, it's not. Every company is building their own solution. So in this case, you have like this deployment object that define how you want to shape the traffic, saying 30% goes in that version and the rest in the other version. And this is the first milestone that we reach with creating this schema that currently is used by frameworks and by different companies to implement in their own way. But then I said, okay, perfect, that is super cool. But if I look into the problem that we're trying to solve here, usually I have an application shell that is calling this service. The service is retrieving from a database the deployment strategy that we want to have and the micro-frontends available, and return back a JSON to the application shell. But this part is a standard. It's like every single system will work the same way. And therefore, with a bunch of colleagues, we created this front-end discovery service. It's open source. It's not an AWS service. It's an open source project that currently quite a few customers are using. And basically, we abstracted that complexity for you. So you just have an endpoint that is available for your application shell to query. And on the backend side, so how can I notify that there is a new version of my front-end? It's just another API that your CI/CD should integrate with. And it's just saying, oh, I've just deployed this micro-frontend into S3 or whatever other service you want to use for serving the micro-frontend. Bear in mind that there is the new version and they want to deploy with 10% increase every minute. That's it. Now, at that moment on, the system takes care about increasing the traffic and assign a token to the user and so on for dealing with that. It's fully serverless in that case, so you pay for what you use and you don't pay a dime more. So that's pretty cool. Now let's move into the value stream responsibilities. So we have same platform, now we move into value stream. So we are at this level here. So this level here, the first thing that they usually talk about is the technology. They have the possibility to choose the technology. And very often, unfortunately, I've seen and I've read articles online that we use micro-frontend because they can do this. So I have multiple frameworks in the same UI. That is definitely a bad decision. ThoughtWorks in 2017 called this a micro-frontend anarchy pattern. So where everyone do whatever they want. Why is it bad? Because in microservices, at the end of the day, you can have a microservice written in Java, another one written in Go, and another one written in Node. Despite I'm not a big fan of, for several reasons, it doesn't hurt anyone. Here, the user, it hurts because you are downloading way more JavaScript than is needed, and therefore performance are hit hard. So it's very important that usually this situation where you have multiple frameworks in the same application is used when you are migrating. I'm moving from an old version of Angular to a new React micro-frontends application. So yes, for a certain period of time, you know that for 6 months, the user will download more. But it might not even download more because maybe the only action that the user is doing is on the old monolith or in the new micro-frontends implementation. So they will never load the other stuff. But in a situation like that, where you have multiple frameworks and they have customers, unfortunately, that optimize for that, you create a lot of complexity for you and for the user. Because standardized, when you are choosing a framework or a language, you are basically bringing into your social technical system a culture. The way how you are designing, for instance, Hack application, frameworks written in Scala that is using an actor model architecture is completely different on the way how you're using, I don't know, Spring Boot in Java. So it's very important that you think about that because there are implications on tools, patterns and other things that you need to be aware of. So majority of the time, try to avoid multiple technologies. The other thing is minimize the code share. This was extremely controversial when I pitched that 10 years ago. And I had a lot of flames on social because they said, oh, Luca it doesn't know the KISS principle, the dry principle, and he's recommending to duplicate everything. Not exactly what I was recommending. So back in the days, there was this gentleman called Sandy Mance. And Sandy was, I showed this slide that was like, say, 2014. Duplication is far cheaper than the wrong abstraction. The problem you have when you're working in as a developer is that the abstraction are extremely interesting because makes you cool, are more interesting sometimes than features. You expect that people are going to use that, but the reality of the day, after 1 year, maybe your library is used by twice in 2 points of the application, that's it. So abstraction are not always the answer. What you are trying to do with micro-frontends is reducing external dependencies. And if you have a shared library, instead you are creating external dependencies. So you need to be extremely careful of what is an external dependency, what's not. Usually there are certain things that might make sense, others not. You want to optimize for fast flow. And if you have external dependencies, you are not optimizing for fast flow because you have the external dependency you can control. Unless you have the possibility to change every given time, but that means even if you change a way how an external dependency works, another thing can be affected. Maybe they don't have bandwidth for checking the sprint, so you need to wait another sprint before you arrive to deliver your stuff. And vast majority of the time, you don't embrace a lean mindset. You just start to create things based on what potentially could be useful in the future, but you don't have that need. And therefore, you're just creating waste, and you never know if it's going to work. So classic example is this. So we have 4 libraries, right? We have logging, analytics, design system, data layer. Which one, in your opinion, shouldn't be a shared library? Any guess?
Shouldn't we?
Shouldn't be a shared library. So a library that is shared across multiple micro-frontends.
Data layer?
Data layer. Bingo. The main thing is rate of change, right? So a good heuristic is data layer are domain specific, and therefore it's more likely that there is a new API or new things that are going to change and affects only a tiny chunk of the system, because not every time, unless it's authentication, not every single system needs to know about specific API. Therefore, that part can be easily, let's say, integrated inside the micro-frontend, and no one will be affected. But if you centralize this part, now, yes, you added just an API, but no one knows if you screw up all the others. Or if you need to coordinate the deployment of this new library or the new version of the library with other teams, because maybe they need to make a change as well. And they are not ready. So there are so many intricacies about the shared libraries that you need to make, that you need to be aware when you decide to have that. So, but design system, high rate of change at the beginning, and then the rest, you don't change the design system every week. Analytics logging, you decide once a year probably, which is the logging library you want to use, and that's it. So these kind of things are easy to externalize and maintain, because the governance is the real challenge. The ownership part is the last bit of this thing. So I expect in 2025 that a team that is responsible for front and back end will own that part. And what I mean is they code it, they test, they deploy and monitor. And trust me, this part is not that given for granted. Very often it's not the case. And last but not least, they adhere to guardrails. So these 4 things is something that they expect. And in order to enforce certain things, you need to embrace a shift left mindset, where when you are trying to merge things, as I was explaining before, you start to provide tools that automate that thing without the need for a developer to think every single time or discover too late. Because too late, it means it adds a lot of time for developers to go back on what they were thinking. And maybe they are busy with another feature, and so another person in the team will pick it up, and they need to start from scratch. So it's very important you start to think about that part. Obviously, as you have seen, so we have a bit of time also for questions. We're not going to, I cover, let's say, a lot of ground, but there is more, obviously. So when we think about micro-frontends, I don't want to underestimate the code challenges. Like server-side rendering is a real challenge. There are a lot of, let's say, practices, and it's not as standardized as client-side rendering. Observability is a new thing for many teams. They are not comfortable to set up, let's say, observability. End-to-end testing it might be a challenge because nowadays you need to work in conjunction with other team in order to handle that. Security, it could be a challenge, but there are things that are slightly different. You need to be more aware of how to design them, but it's not crazy. Events management is a big challenge. So if you think about having multiple events that are bubbling around the system, how you're going to change the schema, how you're going to define what events are bubbling around, all these kind of things, or the governance part of events are important. How you make a change on the schema of an event. Do you create a breaking change? You don't create a breaking change. How you will handle these kind of things. And finally, performance is another thing that you can automate, but you need to think about that upfront, because otherwise you might risk to have megabyte of JavaScript loaded inside the browser of the user without any value. In summary, basically, we have seen what micro-frontends are, how teams, let's say, are owning a micro-frontend or a subdomain, the importance of having a fast feedback loop through guardrails and automation, and finally, embracing this centralized mindset that is not only technical. There is one more thing. So one thing I usually do a lot is like event like this one is also, let's say, sharing off asynchronously other information. So I started a newsletter on micro-frontends. That if you're interested, you can subscribe here. And basically here, it's a fortnightly newsletter where I describe basically case studies. I share resources mainly or experience that I have seen with customers. Or for instance, next one will be on Monday. I'm going to share more about my second edition of the book about micro-frontends I wrote for O'Reilly, and share a few of the updates there. But at the moment, I think is let's say, well received, because it's very informal. You do curation of content and stuff like that. So usually it's something that I encourage people to subscribe. That's all I got. If you have any question, I'm happy to answer now, but also I share my email. So if you want to ping me later on, I'm more than happy to answer questions about that. And with that, I think I shared everything that I needed to share today.
How you compare them with React objects, bigger objects which have multiple.
With the React objects, React at the end of the day is just components. So it's building components. Micro-frontends are a collection of components. And therefore, inside the micro-frontend, you might have like your own state. You have your own components, but that's pretty much it. It's more, up to 10 years ago, majority of the time, front-end developers, they just pick a framework and every decision was made for them by the framework creator. So how React works, how you collocate code in React is chosen by Facebook. In Angular, similarly, how Angular is structured and use certain patterns is decided by the Angular team. And now with micro-frontends, we have a different approach where we need to start to design again the front end like it was in the past. And I think this one is the part that people struggle the most, because identifying a chunk that is independent is difficult on microservices and is even more difficult on front end because people are not used to. Because they're used to think about differently. Oh, there are 2 lines of code duplicated. Let's abstract that. But it's not always the case, right?
And they are usable across applications.
Yes, it works on low-end devices, any browser. It works, no problem at all.
When they reusable, for example, different applications.
Oh yeah.
One microservice may be serving multiple.
Yeah, absolutely.
Translation service.
Yeah, so if you have a translation service, you can integrate in every micro-frontend, no problem at all. Usually, you know, in order to reduce the external dependencies, I will sometimes, you know, I started to segregate the translation based on, at the beginning we had like a centralized translation service, then we segregate that, serving basically talking with the team responsible for the localization service, and start to say, listen, can I pass you an additional information when I request the labels based on the domain that I'm using? So the catalog will see only the localization related to them, and the I don't know, FAQ part will load only the translation related to them. And that basically enables to have way less code shared and less chattiness inside the system and faster response overall. That's yes.
We have online questions from Say. Can you say your question, please? Okay, I'll say it. Any security issues that need to be aware of when constructing a more decentralized structure like front end, or the principles are the same compared to monolithic structure?
Yeah, so more or less are the same. Only thing you need to be, one thing that I've noticed on monolith structure is that people don't take care too much about cores and I don't know, CSPs and stuff like that. So all the, even for instance, for cookies, you know, people are more open up. And they don't, let's say, segregate to the bare minimum, and that's something that the micro-frontends could bite you in. Therefore, it's important that you figure out, for instance, if you define cores and you say, I want to use only this domain can load micro-frontends, you prevent that someone can create an application shell and load your micro-frontend inside their application shell. So you need to understand that part properly. Cookies the same. You can say, I want this cookie that is available only for the subdomain www and only for internal.mysite.com. These kind of things has to be configured properly, and on monolithic application very often it's not. But the logic is the same. You mentioned earlier the navigation mechanism could be full page reload. Are you suggesting to not go towards an SPA approach? No, it depends on what you're using. Server-side rendering, you usually have this approach where you have every single request has to go to the server because the server is rendering the page and serve HTML to the browser. Therefore, in that case, is a full page reload. While if you do client-side rendering, you can have exactly the same approach of single-page application, but it's even better because in single-page application, you load everything in one go. So if you have an application that is 5 megabytes, you need to download 5 megabytes of JavaScript and put in memory 5 megabytes of JavaScript. That on, let's say nowadays, laptop doesn't hurt, but mobile devices in certain countries are not that, let's say, powerful as laptops, and therefore 5 megabytes is a big deal. With micro-frontends, you load a chunk of the application. That means you basically, of the 5 megabyte, you can have like, I don't know, 300 kilobytes. An example that I have is that because I was working on low-end devices like set-top boxes that are definitely not powerful, are more or less with processors like Nokia back in the days, like 20 years ago. Thanks to micro-frontends, we boosted our performance in those devices. Because, for instance, a classic things, a major offender in every application is the SDK for payments. Think about Stripe, think about things. When you have like multiple payments, it means that you are downloading hundreds of kilobytes out of the box. But when do you need payment in a subscription model? Only when you subscribe. After that, you don't load that anymore unless you're changing the payment method. That maybe happens once a year or less. And that means if I'm an authenticated user and I want to go to the catalog, I have 200, 300, 500 or more kilobyte less to load because I'm just loading the experience of the catalog. Therefore, if you work properly inside the boundaries of a micro-frontend and you identify them properly, you might risk that your application, instead of being 5 megabytes, is 200 kilobytes for majority of the user. That's the beauty of this approach. But you can do client-side or server-side rendering, even an edge-side rendering that I usually don't recommend too much because majority of the time, edge-side rendering is basically server-side rendering with data that are coming from a specific region or data center. And data center, not many customers has data centers that are distributed across the globe, but the CDNs are by design. And therefore, even if you're rendering on closer to where the user is, the data are still reside on a specific part of the globe, and you're not gaining much. You're just losing on developer experience and power. So.
But do you really have that much of HTML and Java? Because normally SPA applications load compacted data and at runtime inject HTML into DOM.
Yeah, you load the JavaScript file and then you generate, depends from the framework, but you generate basically a virtual DOM that basically manipulates the data. Yeah, exactly. But it's exactly the same thing.
It's again, but do you really have a megabytes of?
Oh yeah. I've seen, so just to give you an idea, I started to do pair programming with certain developers because obviously working on set-top box is not an easy thing. In order to do the same interface, so the catalog that we have, imagine Netflix, for instance, very similar. We had 45,000 nodes of HTML. When I finished, it was 9,000. Exactly the same UI, exactly the same. But the weight was completely different.
I mean, that was the way you designed your summarization program. But even if you have libraries declared on the top of the page, both JavaScript and CSS, still you will have megabyte of codes in each.
Yeah, because usually JavaScript and it won't be loaded inside the application shell. The application shell load everything at runtime. So it could be that maybe someone forget, for instance, take an example. There are some libraries that handle the dates formatting. That library, if you don't cherry pick which API you use, it could be, let's say, 100 or kilobytes. And if you apply that for multiple libraries that people are using, that is easy arriving to 1 megabyte. So there are techniques like tree shaking and other things that helps you to reduce that thing. But in reality, I have seen megabyte of stuff shipped into the browser easily.
We have another one from
here. So yeah, another about DX. When we are developing a component in Micro-Frontend, how can we make sure the component is matched perfectly with the whole page? In my imagination, we'll only see that single section, not the whole page when we are developing. Okay. So that's correct. But usually what you do on developer experience, you are providing some skeleton of containers that are mimicking the thing. So one of the thing that you do in Micro-Frontends when you do multiple Micro-Frontends in the same view is leveraging the bundler for fetching from pre-production environments, stable Micro-Frontends made by other developers. And basically, you just plug your Micro-Frontend into the page. So you can see the whole thing, how it would look like and work. So for a certain period of time, you work in isolation, as you describe in the question. But then when you start to do the integration testing, if you want, you can physically load stable version from pre-prod, like staging for the majority of the time. And you have your own development Micro-Frontend, and you can see the whole thing together. It's just a configuration thing that you apply.
Thank you. Got it.
You mentioned on the one hand minimizing external dependencies, but at the same time you also mentioned contextual awareness.
Yes.
And context implies
Yeah.
external. So can you just clarify a little bit
Yeah,
the subtlety of that?
Absolutely. So the thing for me is simple. Very often in JavaScript or in front-end, you tend to do like, oh, I have a header, I have a footer, I have these other things. Let's create a components library. But that can quickly escalate on having also, I don't know, the video player and having payment component, all the other things, right? And then you say, oh yeah, but it just compose things. The problem is not technically you can do that. It's not complex. The maintenance is very complex because now if you think about team that should be independent and I have a centralized library and I need to update, now I don't have to test only my part. I need to test also your part. And then if that is used across multiple micro-frontends, everyone has to test these things. So we are creating a nightmare for developers. If that is the model you want to pursue, better monolith. If you want instead to decide to go, okay, I want to reduce the external dependency and move fast inside the things, you focus on few libraries that are really valuable for your company, design system, logging, stuff like that. But for instance, you ask yourself twice, is it really needed to have a header shared? And you might say, oh yeah, but how can you create the similar header across the application? To be honest, in my previous application, the header was duplicated 5 times. If a developer cannot create a simple header with few links, we have bigger problems than the micro-frontends. And the reality is, if I check the rate of change of the header changed in 3 years once. So do we have any value of finding a team that is responsible for the header, creating overhead for that team, and so on and so forth, while we can just create a ticket for every single team, build that, oh, you need to change a voice. Okay, all the teams that has this element, the item inside the header that we change done. It's more the burden of creating the ticket that the developer updating the header and stuff like that. So you need to balance the context awareness. You need to balance this thing. There are other things like Amazon. The header is extremely complex because it depends if you are in Amazon Fresh, if you are in Amazon.com, if you are in a specific category, the header evolves, changes. And that for it is you need a team that handles that. So the context is shifting, let's say, decision very easily. That's why, for me, it's always trying to have clarity of what we want to express inside the system and understand the context. That will lead you to say the header might be shared or not, or this specific element could be shared or not. For instance, payment, for me, I decided to share it for one reason. It was needed only in 2 micro-frontends. Because I want to force every team to have the latest version of the PayPal SDK or, I don't know, Stripe SDK, whatever. Because if I didn't do that, a team could have a version. I sign up with one version of PayPal tomorrow, and when I update my payment methods, I go with another version that might not be compatible, and I cannot control that. And therefore, in order to force that, I create friction. That was my decision on creating friction, because I want to have a single point that every time this is changing, I basically need to block the teams, because it was so much important for us that we nailed it. Another thing that we shared was a video player, because the video player was extremely complex. And therefore, it handles like live streaming is complex by itself, but the video player is another level. And that we wanted to have something that was, let's say, centralized. And we created, for instance, one solution that was custom solution. So in JavaScript, every library has a SAM versioning approach. So you have major, minor, bug fixing. So we decided to have creating a loader for the video player that was available on all the micro-frontends that needed the video player. And the only thing that the micro-frontends needs to set is the major version. The minor and the bug fixing was always the latest, because the logic that we created was you rely on the major version that is expressing the package JSON, but the minor and bug fixing version will be dynamic, will be the latest always. And this approach enables us to avoid breaking changes, because the team knows on the video player side to not bump up the version of to don't introduce a breaking change in minor or bug fixing version, but only if there is a major version. And so we had control on behaviors. Once again, first identify what was the problem, how to solve that, and then we did the brainstorming in order to find the best solution for embracing these characteristics. And that's why, for me, it's context awareness and the reduction of sharing. Because where it's needed, do that. But where it's not needed, embrace even duplication is no problem. And sometimes, with duplication, you understand better what you need to abstract. Because when 2 teams are working parallel, and they are building a specific thing, then after X months, they can say, okay, so we have this in production. What are the similarities? How the requirements evolved in a specific area? And then decide if to abstract them now. very often, you know, at the beginning, it's a bit fuzzy how much you want to abstract. So it's not, let's say, a huge issue in certain things. Certain others could be a problem. Yeah.
Sorry, Luke, can you put up the Micro-Frontends newsletter QR code again?
Oh, yes.
Yep. Thank you. Great. Got it. Thank you.
You're welcome.
Any other questions in the? Are there any other questions online?
No, I don't see that.
No, thank you very much, Luca.
Oh, there is a question here. Any strategy to decide how to distribute the budget size for each micro-frontend, or we set a baseline and start from there? We set a baseline and start from there. So when you have a first micro-frontends and you are more or less optimized and happy with that, you define the baseline and then you build a system for handling that. There isn't right or wrong there. Sometimes, you know, if you are working on a B2B system that is behind authentication, even if you ship a larger bundle size, no one will scream because people are going there, like imagine a bank, to they do specific things. So at the end of the day, you know, you need to define these things. Obviously, rely on the core web vitals and the recommendation, like Google suggests, a page should be loaded in less than 4 seconds. Those are usually the rule of thumb that you use to follow. Cool. You're welcome.